So write what I write.
Let's play that game. Wow.
That game. No strap. Nope, not at all. Yep. Or.
Nope, already got it.
I'm done.
So I've been talking to your math teachers,
Uh-oh. Oh, no. I know.
and they tell me that students typically will struggle with this as they're learning algebra. Solving literal equations. So we have a couple of literal equations that we've been working with. The energy equations, GPE and kinetic energy. Gravitational potential energy is equal to the mass times the acceleration of gravity times the height of the object above the surface of above the reference surface. And the kinetic energy is equal to 1/2 times the mass times the velocity of that object squared. We have already worked some problems where we're calculating the gravitational potential energy, and all we do is simply multiply the mass times the acceleration of gravity times the height. We've solved some kinetic energy problems where we're multiply 0.5 times the mass times the velocity squared. Life isn't always so easy, because sometimes we get a problem where we're told what the energy is and the velocity, and we need to find the mass of the object. So we're given a problem where we have to solve for one of the other variables in the equation. And some of you all are right at the point where you kind of know how to do this, you're kind of struggling with it, and so for the last couple of tests, I've been giving you the magic triangle, right? So let's take a step back from our energy equations and look at another literal equation, which you're probably a little more familiar with, and that's, Newton's second law. We've just come off the unit of talking about. Wait, let's not copy this because I'm just providing you a little bit of background, okay? F equals ma, you know that equation. You know that the first problem that I gave you had to solve for the force by multiplying the mass times the acceleration. And then the second problem was solve for acceleration given the force and the mass. And you're like, wait a minute, Mr. A, we don't have an equation for that. I'm like, yeah, we do. There's this equation. You just have to rearrange it. Well, we don't know how to do that. And I said, okay, for you, my friend, I will give you the magic triangle, right? So I made this thing right here. And I said, if you want to know the force, then you cover up the F, and it's m times a. Now, if you want to know the a, then you cover up the a, and it's F divided by m. And you go, wow, that's pretty cool, Mr. A. Likewise, if you wanted to know what m is, you cover up the m, and it's F divided by a. So you don't have to write these down in your notes because you already know these, right? But there's nothing magic about it, right? It's really just algebra, right? So let's, for example, the algebra that we actually use to get those two, if we wanted to solve for a, what do? You divide by m. You're trying to get a all by itself, and so in order to undo the multiplication of m, you have to divide by them. You guys say you don't know how to do it. What you need to know how is to undo, right? You need to know how to undo m times a. Well, you undo that by dividing both sides of the equation by m, okay? And then you have to recognize that if I have m in the numerator and m in the denominator, then those two are going to cancel out. And if I just flip this around, then I have a is equal to f divided by m, right? That's what we had before with the magic triangle. Likewise, if we wanted to solve for m, now, Caballero, what do I do? If I want to solve for m, Caballero. I divide by a, right? So I divide this side of the equation. Whatever I do to this side of the equation, I have to do to this side of the equation. And if I have a in the numerator and a in the denominator, yes, you guys are all rolling your eyes in the back of your heads because this is so easy. right? Then why do we choke when we get to the energy equations? Because they're a little bit different. There's more than 3 variables, and one of them is a square. Oh no. Okay. All right. Let's go back to the energy equations. Let's not be fooled by magic. Let's use science. All right? No, in this case, mathematics, right? Let's take, first of all, we're going to go back to your notes. You've already written GPE is equal to MGH. Nick, pick a variable to solve for. That's not GPE. You want to solve for G? Is G a variable? We know what G is. It's not varying. It is always what? It's an acceleration of gravity, which is equal to? 9.8. Let's give it some units. Very good. Okay. You want to solve for M? Okay. Hildebrand, what do I want to do if I want to isolate M on this side of the equation? Divide by G and H. Can we do both of those at the same time? Yeah. Such a thing has never been done before. Let's try it and see what happens. We're going to divide this side of the equation by G and H. And we're going to divide this side of the equation by G and H. So if we have G and H in the numerator and G and H in the denominator, we can cancel those out. And lo and behold, we have M is equal to GPE divided by GH. Everybody put a box around this equation in your notes, because you're going to need it today. And you're going to be able to want to find it quickly. Totally. I'm alive and well serious. Happily married with 8 hours of sleep serious. Okay? You got that? Got it? Pardon me? GPE, gravitational potential energy, divided by the acceleration of gravity times H. Okay?
What is H?
H is the height of the object above the ground. Okay? All right, let's go back to our original equation. You're not erasing, you're just, you're going to, maybe what I would do is maybe rewrite this now again, a little lower on your page. Next, right, rewrite the gravitational potential energy equation. Now we are going to solve for the only remaining variable, which is H. Yes. Remember that this is the mass of the object. You don't have to write this if you know it. Driscoll was trying to remind yourself that this was H for the height. And this is the acceleration of gravity. Which is a known 9.8 meters per second squared. We are calculating gravitational potential energy. Okay, now we want to solve this for H. Who else wants to try a shot at this? Who said? Vajegas. We want H alone on this side of the equation. So what do we have to not necessarily do? What do we have to undo? We got to undo the multiplication by mg. So how do we undo a multiplication? By dividing, right? So what am I going to divide both sides of the equation by? By mg. Can you see now that you can eliminate m, you can eliminate 8, G, I'm sorry, I was trying to eliminate 8. I can eliminate g, and if I now I have h is equal to GPE divided by mg. Put a box around it in your notes. You're going to have to find it later. I like you to circle your numerical answers. and box your equations, but whatever floats your boat. Okay, now let's move on to the kinetic energy equation. All right, so Ms. Driscoll reminded me that I should probably point out what these variables all stand for. So this is kinetic energy. Is equal to 1/2, or you could say 0.5, right? Is equal to 1/2 the mass times the velocity squared. Okay? You've already solved some problems for KE using this equation. Let me rewrite this slightly differently to make our job easier. We're going to be 1/2 mv squared. Isn't this the same as mv squared divided by 2? Is it? Okay, good. If I've divided this side of the equation by 2, what do I have to do to undo that? I got to multiply by 2, right? So let's multiply this side of the equation by 2 and this side of the equation by 2. If I have a 2 in the numerator and 2 in the denominator, hocus pocus, voodoo math, I can make those go away, right? That leaves me with 2ke is equal to mv squared. All right, I'm trying to isolate for m now. Wadsworth, what do I got to do to get just m?
Divide by v squared.
Yes, you divide by v squared. You don't just divide by v because that's not just v, that's v squared. But it's just a symbol as far as we care right now. It's v squared. Divide both sides by v squared. If I have v squared in the numerator and v squared in the denominator, I can make those go away. I'm just going to turn this around, and mass is equal to 2 times the kinetic energy divided by the velocity squared. Put a box around it. Put a box around it. We got one more to do, and we will have covered all of the variants of the energy equations. I don't know if that's what they actually call it, but I like that. All the different models, all the different styles of the energy equation, right? The energy equation solved for all the different variables. Okay? Now, this is the one that if you don't have the algebra skills, you're going to struggle with. And if you haven't worked a lot of these problems with a calculator, you're going to struggle with entering them into your calculator because the keystrokes that you enter, the order of the keystrokes, the operators that you use are important. Okay, so we're going to do lots of practice today. Okay? Let's solve for V. De Felipe, what do I do to solve for V? Okay, to get the mass on the other side. What is that? We're struggling. I do. Okay, 1/2 or 2 in the denominator. I'm dividing by 2, so what do I have to do to this side? I have to multiply by 2. All right, so I'm going to multiply by 2, multiply by 2. So those are going to go away. Okay. Now I got 2ke is equal to mv squared. I'm trying to isolate v. What do I do now? Kathleen, what do I do now?
Oh, you have to get, did you divide by m?
Yes, I would. Okay, so let's divide this side by m and let's divide this side by m. Those two m's go away. Now I got 2ke divided by m is equal to v squared. I don't want v squared. I want v.
Divided by 2.
Careful.
Wait, then divided by v.
Lawrence. Ding, ding, ding. How do you undo a square?
Oh, square.
Square root. You have to unsquare it, which is square root, right? So whatever I do to this side of the equation, I have to do to this side of the equation, right? Make sure you draw a great big radicand. This is called the radicand. Make sure you draw a great big radicand, which includes all of your variables on this side. Now, you just said that a square root undoes a square, so now I can erase those symbols. And if you want to turn it around, it's V is equal to the square root of 2ke divided by m. Okay? Put a box around it. You might even want to put that on a flashcard, because it's going to come up again. Okay?